This video will be a demonstration of how to install and run InterroBench. And for this demonstration, I'm using a stock version of Ubuntu, completely fresh install. So firstly, we're going to go to the InterroBench website. And we go to the code. So it's just a GitHub project, so you check out the code the way you would any GitHub project. You copy the URL. We need to find the Ubuntu terminal. There we go, let's pin that. So the command is git clone. Let's make a directory actually. Git clone. So we don't have git installed because this is a stock Ubuntu, so we just do that. Cool, that's it. So basically the README on this page does give you some basic instructions. So if you want to run the benchmark yourself, you need an account and API key for whichever provider you want to use. So I won't be explaining how to do that, but if you just Google OpenAI API, you can sign up and get yourself an API key. And you need a computer to install Python and Postgres on. So check out the code, we've done that. Install Postgres. So we need the Postgres server and client, and we need libpqdev, which is does for the driver for how Python talks to Postgres. So if I remember correctly, all we need is this machine is Ubuntu 24.10. All we need on this is Postgres all. And this gives us everything we need. We've got the client, the server, and libpqdev. Cool. So now we just need to do some more installing to get the Python stuff. So Python 3 pip, and we need Python 3. So I'm going to use virtualenv wrapper. It's just a more convenient way to manage virtualenvs, but you can do it how you wish. Cool, so the next step is create a Postgres database and user. So because I can never remember the steps, I have a page on my personal website for this. Yeah, so we've already done that. So ideally you shouldn't have to sudo to manage Postgres, but this fails because we've got no role for our Joseph user. So what we do here is sudo -u Postgres. So we're going to set it up so that we won't need sudo in future. we need an empty database with our name. And then if we just do sort of du, we can see the users. Cool, so we've exited out of sudo and we can now connect, great. So now we just need to create the database for our application. So I'm going to call both the user and the database InterroBench. What did I just type? Create user InterroBench with password. We don't care about the password because it's just localhost. Cool. You can see our database. Cool. So we've created our database and user. Create a couple of config files. So we need our text editor. Ubuntu comes with this one. So if we just copy. So I'm just going to, for the purpose of this demo, I'm going to customize this a bit. So instead of a best of 5, we'll do a best of 1. We need this to be quick, and we'll set it to easy problems only, so it just does the first 3 instead of the entire set. Oh, and before I save it, yeah, let's use GPT-4o Mini, because I think that's the cheapest model I have access to. Although, I think I might still have some free credits with Grok, but anyway, so if we go to repos, InterroBench, create a directory, resources, and this one is called config.yaml. Cool. And then we need to create our credentials.yaml. So just put your user here. Okay, so you need your API key. I'll just copy mine in. Obviously, I would change that before I publish this video. Credentials.yaml. Cool, that should be it. Cool. So make a virtual env and activate it. So we're using virt we're using virtual env wrapper, and you need to just add it to your shell config. So on Ubuntu, the shell is on Ubuntu. Can I not tab between these? On Ubuntu, the shell is just bash, so we'll be adding it to our bash RC. So where has apt installed this file? Because if I remember from trying this before, yeah, cool. So we just need to add that to bash RC. So echo source. That should do it. Cool. So if we just make a new terminal, right, you can see it's initialized virtual env. So now we can do mec virtual env. Call it what you want, but Yeah, that's worked. So you can see at the left-hand side of the prompt that the virtual env is active. So we're ready on that front. Okay, install it into the virtual env. So this will install all of the project dependencies. This this project uses a setup.cfg, so it's just installing all of this stuff from here. This is the part that would fail if you didn't have libpqdev. Okay. Right, so we're using Alembic to manage our database migrations. So this will create the tables in the database. That looks successful. Let's just check. So if we connect to InterroBench and list the tables, yeah. So it's created our attempts and runs table. And these are sequences for the IDs. This table is just its metadata. Cool. So if you want to run the project tests, which isn't necessary, but that's very easy. You just do this to pull in the development dependencies and run pytest like this, or pytest. It always prints these warnings, but the test's passed. Anyway, so now we're ready to actually run InterroBench. So just a recap of what settings we're using. So we're doing a best of one with GPT-4o mini, easy problems only. Cool. So I'll actually give you a quick tour of the code while this runs. So essentially if we go in circ InterroBench, so there's two main phases to each problem. So for each problem, firstly, there's the interrogation phase where the LLM will call the function repeatedly to figure out what it thinks it does. And that's handled by interrogate.py. And then there's the verification phase afterwards where the system will run some verifications and get the LLM to predict the output in each case. Now, in interrogate is basically all the problems, and interrogate is the subject of interrogation. So here's the actual test function, the mystery function that the LLM has to test. In this case, it's a very simple Boolean AND, 2 arguments. And here is the metadata which the system uses. So the verifications are, in this case, just pairs of Booleans. So when the verification phase starts, the system will evaluate these to find out what the correct answer should be, and it will ask the LLM to predict that. So that's how it knows that the LLM has got it right. And if you're curious to see what the prompts are, if we go to interrogate, so you can see right here the initial messages that start the conversation. So you've got your system prompt. So a system prompt gives the LLM general instructions of how to behave. And then we've got the human message, which it's just called a human message by convention, but it's really just the message at the start of each, each prompt, each question. And yeah, in the verify.py, you've got the prompt for the start of the verification phase. To test your theory, please tell me what's the expected output. You no longer have access to the tool. Anyway, so if we go back to the program output, so the run is finished. So let's walk through it a bit. Right, so this is telling us that we're starting the interrogation phase for function AND. So the LLM has been given a mystery function. It doesn't know what it does. So it's telling you, I'll begin by testing the mystery function with different combinations. Now, the LLM is allowed to do multiple tool calls in one go, which it has, which is sensible in this case. I've tested the mystery function. From these results, it appears the function returns true when both A and B are true. This behavior suggests it's performing a logical AND, so it's got it right. So the system should now move on to the verification phase, which it is. So it could probably get all of these right. So that's essentially how it works. Then function OR, which is equally easy. But even the really low end LLMs get these Boolean ones correct. If you have the best of setting set to a higher number, it just means that each one of these will be done repeatedly until it either succeeds or fails at least 3 times. That's what a best of 5 is. So that you can see it failing, we'll run it with all the hard questions. Just uncomment hard problems only. Right, so count ease is basically the function takes 2 strings. No, it takes 1 string and it just counts the number of e's that occur. This is quite a hard one for them to figure out. They often think that it might be counting vowels, but they don't figure it out. It seems the function may be returning integers based on the input strings. So on the previous example, you probably saw it was normally just running one round of tool calls, but because it's having trouble figuring it out, it's likely to try a lot more combinations. It's not really on the right track here, is it? Sometimes by this point, it would at least mention the theory that it might be counting certain characters. It appears the mystery function classifies strings into 3 categories, so this is a failure. So the system is now moving on to verifying it. So the system is asking it what output it would expect from that. It actually got it right by chance. I'm going to have to change the verifications to not use common words like hello, because the LLM literally tried that. Yeah, in world as well. It probably already tested world. This is a change that's in the pipeline. But the third one is obviously something it didn't try. So it gets it wrong. Contains a substring. It's also quite a hard one for them. Right, so in this case, it's actually failed to call its tool correctly or something. The mini models often do this. The frontier models almost never cause errors, but basically what it means is that the LLM has failed to follow the formatting that it's been told to use. Anyway, so yeah, this one's super hard. None of them are going to get that. So that's what it looks like when you get failures. Is there anything else worth showing you? Oh yes, the database. So the reason there's a Postgres database is so that we can analyze the results after the fact. And you've got the full power of SQL. So if we do select, well, let's just look at the schemas first. So if we look at runs first, so the runs table includes things like the start time of the run, how long it took, the final score, which model was used. Our ID is important because that allows us to reference it to the attempts table. So if we just do select a few interesting ones. So now if we take the ID from one of these, so select so we can now see, I mean, this is a bit too much output, so it doesn't fit, but so yeah, function end, result true, time taken, number of tool calls used, and then if we scroll to the right, you can see the full log. So, this is super helpful. So you can, well, for example, you can list all of the attempts that were failures, right? So you can do select all from attempts where, I forget the schema, select all from attempts where result doesn't equal true. Yeah, so those are just the 4 from our second run. So, you can do all sorts of analysis and find specific runs. So I think that's essentially it. That's the end of the video.